Now we're looking at question 6, the question on probability. Let's take a look at the question first. We have three events here, A, B, and C, and the information given as such is probability of event A is given by lowercase a, probability of B is lowercase b, probability of event C is lowercase c. And furthermore, you are also given that A and B are independent events and A and C are mutually exclusive events. Now you have to find expression for PA complement intersecting with B complement. And hence, that means using this result, you have to prove that A complement and B complement are independent events. Okay, so more or less you should know what to do. All right, so first of all, we have to understand that in order to find probability of A complement intersect B complement, we have to make use of the complement, which is 1 minus PA union B. Okay, so straight away you should write this down. All right, and how do we find A union B? Probably A union B would be PA plus PB minus PA intersect B. But because the question also says that A and B are independent events, so that will give us probability of A intersecting B equals PA multiplied by PB, which is A times B. So that is how we obtain this. So after we gotten PA union B, we then substitute into this expression here, and we will get the answer for PA complement intersect B complement. So that will solve the first part. Then as for the second part, the question say, hence we have to show that A complement and B complements their independent events. So remember, in general, how do we find? If two events X and Y are independent, we have to show that X intersecting Y is PX multiplied by PY. So this is what we have to show. Okay, we need to show this. So on one hand, we already know the answer for this PA complement intersect B complement. That is your left hand side. Then right hand side, we have to compute PA complement multiplied by PB complement, which is of course 1 minus A times 1 minus B expanding. We have 1 minus A minus B plus AB. So you can see by comparing, the two answers are the same. So therefore, we establish the conclusion that A complement and B complement are indeed independent events, since this is satisfied. Okay. All right. So that was settled the first part. Now we move on to part 2. Part 2, you are asked to find an expression for A complement intersecting C complement, and then you have to draw a Venn diagram to illustrate the case where A complement and C complement are also mutually exclusive events. Okay, so let's try to solve this. Okay, A complement intersects C complement using a similar idea as part 1. We have 1 minus PA union C. Okay, but because the question right from the start, the question already told you that A and C are mutually exclusive. Okay, where you can find this information from here, right at the start. So never leave out any information. So therefore, we know that A union C, which is PA plus PC minus PA intersect C. PA intersect C will be equal to 0 because of A and C being mutually exclusive. So which means that it is equals to PA plus PC, which is A plus C. So this explains this answer here. So with this, we got the answer for PA complement intersect C complement. Okay, on the other hand, because the question also told us that A complement and C complement are also mutually exclusive events. So how does it impact the answer? So if we use this information, it means that A complement intersecting C complement equals 0. But we have already found the answer from here. So we apply this result, we equate 1 minus A minus C equals 0. And that will give us A plus C equals to 1. So what does it mean? If A plus C equals to 1 means that your probability of A plus probability of C equals to 1. That means they have filled up the entire universal set, because you know that for universal sets the probability is 1. So if PA plus BC just nicely equals to 1, that means events A and C, when you combine them, they are the universal set. And plus the fact that A and C are mutually exclusive, so there won't be any overlapping between A and C. So this is how you should draw the Venn diagram. Okay, notice that events A and C, there is no overlap, and together they form the universal set. Okay, so if you want to, you can also write like this, universal set. So that is the answer for question 6. Okay, now let's move on to the more difficult part. You are now given that A complement and C complement are no longer mutually exclusive. Okay, and we know further information. Instead of PA equal to small a, we are given numerical values. We have PA equal to 2/5. We are also given PB intersect C equals to 1/5. And A complement intersect B complement intersect C complement is 1/10. Okay, what I want to emphasize over here is that probability of A complement intersect B complement intersect C complement by De Morgan's law, it is given as such, right? So which means that it is 1 minus PA union B union C, all right, which is 1 over 10. So you have to be mindful about this piece of information, because in order to solve part 3, we need the Venn diagram. Okay, we need the Venn diagram. So therefore, if you look at the Venn diagram, so this is how it should be. Okay, first thing is, we know that A and C are mutually exclusive. So this is one piece of information, still true. So therefore, A and C will not overlap. Okay, then furthermore, we also know that 1 minus PA union B union C is 1 over 10. So where is A union B union C? Is this portion here. So which means that if I have 1 minus PA union B union C, which is 1 over 10, that means I have some values which is outside A union B union C, but still inside the universal set. Okay, so this is 1 over 10. All right, so always be careful whenever you're solving such question. Don't just focus on A, B, and C or whatever events you have. You should always look at the region beyond these events and see whether there are any other probabilities over here. Otherwise, your Venn diagram is not considered as completely correct if you miss out any information. Okay, all right. So now we are going to solve the question. Eventually, what is the question we want to solve is that we want to find the in exact value, that means in fraction, the maximum and minimum possible values of PA intersecting B. Okay, but before we arrive at that step, we need to complete the Venn diagram first. Okay, so we know that B intersecting C is 1/5. Okay, B intersecting C is 1/5. So you can put this in first. And we also know that probability of A is given as 2/5. And the question also told you that A and B are independent events. So which means that I can easily find A intersecting B, which is equals to PA multiplied by PB which is 2/5 B. Okay, 2/5 B. So this is how I got the answer. Okay, so maybe let me erase all this first so that it's clearer. So given that A and B are independent, so PA intersect B is PA multiplied by PB, which is 2/5 B. Okay, so this is my answer. And which means that because we know that PA is 2/5, right? So which means that here remaining portion is 2/5 minus 2/5 B. Okay, then what about B? What about B? So we know that for if we look at the question, probability of intersecting C is 1/5. So therefore, the steps that shows here is how you get A intersecting B complement, which is this step. Okay, we also settled 1/10, which is outside PA union B union C. Okay, then we move on to this part. Okay, C intersect B complement. The probability of B is given as small b, okay, which is reflected as here. All right. So if we apply this, we will know that this part is B minus 2/5 B minus 1/5. So that will give us 3/5 B minus 1/5. Okay. Then to find this portion here, we will take whole thing, which is 1, minus 1/10, which is outside, and minus all this, So as a result, your probability here will be given as 1/2 minus 3/5 B. Okay, the working is reflected here, 1 minus 1/10 minus 2/5 minus 3/5 B. Yeah, okay, which is equivalent to subtracting all this in green color. Okay, so this is how you arrive at 1/5 minus 3/5 B. So after you have filled up the Venn diagram, notice that all the probabilities must be non-negative. So there are few values that in terms of B, one is this, 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 and this. Okay, so I have 1, 2, 3, 4. So all these must be non-negative. So that's why the next step is you consider the following. If I have 2/5 minus 2/5 B more than or equals 0, which is number 1, B must be less than or equals to 1. Then if I consider number 2, 2/5 B more than or equals 0, I have B more than or equals 0, of course. Number 3, I solve this, I have B more than or equals to 1/3. And number 4, I have B less than or equals to 5/6. So all these must satisfy together, okay, because they are part of the Venn diagram. And after you gotten all these answer, we will have to take intersection, which is B between 1/3 and 5/6. Okay. So after you gotten the range for B, now the question is asking you to find the maximum value of PA intersect B as well as the minimum value. All right. So A intersect B, remember, is given by 2/5 B. So in order to maximize or minimize A intersect B, it is the same as maximizing or minimizing B. So in other words, if I maximize B, I maximize A intersect B. If I minimize B, I minimize PA intersect B. So therefore, to find the maximum value of PA intersect B, I have to take the maximum value of B, which is 5, 6. So likewise, if I want to find the minimum value of PA intersect B, I have to consider the minimum value of B, which is 1/3. All right, so when I substitute in, I'll get two answers respectively. Maximum is 1/3, minimum is 2 out of 15. 2 out of 15. So for this question, we have completed, but just want to remind all of us here is that to solve this kind of question, it's very important to make sure that every single portion of your Venn diagram is complete. We have similar question in your tutorial, mastery question for probability as well as WA. Please go and practice that. Okay. And another thing I want to remind all of you here is that anything outside the A and B and C, right? But within the universal set, always make it a point to check whether there is any remainder value here. Okay. All right. So with that, we have ended the review of question 6. Thank you.